Let's solve a problem which requires the application of RHS rule of congruency. Here is our problem. Identify the congruent triangles in the figure below. So here we have three triangles. This is triangle 1, triangle ABC. This is triangle 2, triangle DEF. And this is triangle 3, triangle PQR. We have to identify here which pair of triangles is congruent. Let's first compare triangles 1 and 3. So this is triangle 1 and this is triangle 3. Important thing which we should keep in our mind regarding triangle 3 is that this angle here is not given to be 90 degrees. Although it looks like a 90-degree angle, but it is not given here. So we will not take this angle as a 90-degree angle. When we look at triangles 1 and 3, we do not have any corresponding paths which satisfy any rule of congruency. So triangles 1 and 3 are not congruent because no corresponding paths satisfy any rule of congruency. Now let's compare triangles 2 and 3. In triangles 2 and 3, we can see that PQ is equal to ED is equal to 3 centimeters. QR is equal to FE is equal to 4 centimeters. But this included angle is not given to be 90 degrees in triangle PQR, so we cannot apply SAS rule of congruency for stating these two triangles as congruent. So in triangles 2 and 3 also, we cannot say they are congruent because angle PQR is not equal to 90 degrees. Therefore, SAS rule cannot be applied here for stating the two triangles as congruent. Let's compare triangles 1 and 2. In these two triangles, we know both are right-angled triangles. So, angle BAC is given equal to angle FED is equal to 90 degrees. So, these two are right-angled triangles. Then, we are given that AB is equal to ED is equal to 3 centimeters. So we can write AB is equal to ED is equal to 3 centimeters. So one pair of sides is equal. But what about the hypotenuse? Here in triangle ABC, we know the hypotenuse is 5 centimeters. But in triangle DEF, we do not know the measure of the hypotenuse. Let's use the Pythagoras theorem to find the measure of the hypotenuse here. Hypotenuse DF square will be equal to 3 square plus 4 square. That means DF square will be equal to 25 and DF will be 5 centimeters. So very easily, by application of Pythagoras theorem, you can find the hypotenuse DF to be 5 centimeters in triangle 2. Now we can see that the hypotenuses in triangles 1 and 2 are also equal. So we can write here BC is equal to FD is equal to 5 centimeters. Now, from these three pairs of data, we can apply the RHS congruency rule for saying that triangles 1 and 2 are congruent. Therefore, we can say that triangle ABC is congruent to triangle DEF by RHS congruency rule. Let's summarize what we have done in this problem. Here we were given three triangles, out of which Triangles 1 and 2 were right-angled triangles. In each of the triangles, length of two sides is known. In triangle 1 and 2, both were given to be right-angled triangles, and one pair of sides was given to be equal. We did not have information about the other pair of sides, that is the hypotenuses, so we made use of Pythagoras theorem in triangle 2 and found out the measure of hypotenuse DF. Then we fulfilled the RHS criteria between triangles 1 and 2 and proved them to be congruent.